so we divide by 2 there. We get y equals 4 plus or minus the square root of x plus 3 over 2. And this is our inverse. When you have a plus or minus, you do not change this back to the f inverse notation because that plus or minus makes it not a function. So we technically aren't supposed to change it back. If you do, I usually don't count off for that, but technically it's not a function, so we don't change it. Our textbook does, but other textbooks don't, and I feel like it's probably not best to use function notation, but it's not a big deal either way. Okay, questions on that one? Okay, let's do another one. Okay, so for example 2, we've got f inverse for f of x equals 1 over x plus 2 squared. So what we'll do here, we're going to think of that f of x as a y right there. And we've got to switch where they're at. So x equals 1 over y plus 2 squared. Now, whenever we deal with this, the biggest thing to remember for these is that you cannot solve for anything that's in the denominator. So we're trying to solve for this y right here. But right now it's in the denominator of a fraction, and you cannot solve for anything that's in the denominator of a fraction. So what I'm going to do is I'm going to multiply this whole thing by y plus 2 squared on both sides, because I can't do anything with that y if it's in the denominator. Okay, so if you have a y in the denominator, you need to try to get it to the numerator first. So that is going to be, I'm going to leave that factored, x times y plus 2 squared equals 1. Okay, we are right here. Now it is in, the y is in the numerator, so now we can solve from there. So, what would we get rid of first? The x. How do we get rid of the x? I'm here, multiply, add, divide. Right now it is multiplied by that parentheses, right, because it's right next to it. So to undo multiplication, we divide. So we divide by x. That cancels there. So now we have y plus 2 squared equals 1 over x. Okay, so Levi, what would we do next? Good, we got to get rid of that square. And how do we get rid of a square? Square root. So we square root both sides. What have we got to remember when we square root both sides? Plus or minus. So put plus or minus square root of 1 over x. And then the last thing that we need to do here, Jonathan, what have we got to do? Subtract that 2. Again, you can put that on the end, but I usually put it here, negative 2 plus or minus the square root of 1 over x. You have a plus or minus in this one as well, so don't use that function notation. This is not a function if it's got that plus or minus. You also may see it written like this, y equals negative 2 plus or minus 1 over the square root of x. You can do that because you can take the square root of the numerator and the denominator separately, and the square root of 1 is 1. So we can take the square root of the top and just leave the bottom with the square root. So you could see it either way. I don't care which way you leave it. Just know those both could be possibilities. Okay? Questions? Yes. You can ask questions. I don't think it's going to pick you up. It doesn't even pick me up very loud. All right. So for our notes here, so the x and y coordinates are switched for y equals x symmetry. We skipped some symmetry stuff that I used to do, which is fine. But if the x and y coordinates, if we switch x and y coordinates, it means that we have symmetry over the line y equals x, so we could fold it over that line. F inverse of x is the reflection of f of x over the line y equals x. Okay, so I told you already that if we get a plus or minus when we're solving these algebraically, that's not a function. If it has a plus or minus, it's not a function, so we don't use that f inverse of x notation. Sometimes our homework is going to ask us to look at the graph and tell whether or not the inverse is a function. Let's look at the problems that we'll have here. If we have a graph like example 3 here, this is our original function. If we took these points, that one's not on there. If we took these points and we reflected them over the line y equals x, that would mean we'd switch our x and y coordinates, right? So 0, 0 would stay where it's at. 1, 1 would stay where it's at. But 2, 4 would be 4, 2. Which would be about right here. And 1, negative 1 would be negative 1. Negative 1, 1. Hold on, I need to write it down. Negative 1, 1 would become 1, negative 1, which would be right here. Right? And then negative 2, 4 would be 4, negative 2, which would be right here. So if I reflected it over that line y equals x, it's that diagonal line that runs through the first and third quadrant, then I would get a graph that would look like this. This graph is a function, but its inverse is not, right? Because the inverse, remember that we test for a function to see if it is a function by doing the vertical line test, and the vertical line hits more than 1 point on the inverse. So on this one, f inverse of x is not a function. Now, there's a way we can tell that without having to try to actually graph it, because I think the reflection over the line y equals x is kind of hard to picture sometimes. Folding it diagonally there is hard to picture. So the way that we can tell without looking at these points is that we know a vertical line test tells us whether or not it's a function. If we do a horizontal line test, it tells us whether or not the inverse is a function. So you can see here that this does not pass a horizontal line test, so the inverse is not a function. Okay. For example 4, is the original a function? Okay, the original is not a function. But if we do the horizontal line test, oops, that's not what I meant to do. If we do the horizontal line test, the inverse is going to be a function, right? So although the original is not, f inverse of x is a function. So if you have the graph of the original, if it passes the horizontal line test, then its inverse is a function. Okay? So if we look at 5 here, is the original a function? Yes. So I'm just going to do f of x. That's a yes. What about the inverse? Okay, the inverse passes the horizontal line test, so it is also a yes. These are special functions that we call these are special functions that we call one-to-one functions. I don't think our textbook asks us about that much. I'm just throwing that in there for free. So if your inverse and your function are both functions, that's called a one-to-one function. It means every number has only one partner there. If we look at example 6, what about the original? Is it a function? Okay, original f of x is a function. I'll put a yes. What about the inverse? Okay, it is not. Yep, horizontal is the inverse. That's for the negative one. Vertical. We do a vertical line test. Yes, vertical line test to see if the original is a function. And then we'll do a horizontal line test to see if the inverse is a function. Okay, questions? Okay, there's one more thing we've got to do. Tomorrow on your quiz, the 2 inverse questions are multiple choice questions. So you could find the inverse like we did at the beginning. There's also, if you're getting stuck with that, there's also another method that you can use to check to see if 2 functions are inverses, right? I said at the beginning that inverses undo each other, right? So if I plug in 1 and get 7, then when I plug 7 into the inverse, I should get 1, right? It undoes what was done. So if 2 functions are inverses, then f of f inverse of x or f inverse of f of x should equal x. Okay? So do you guys remember seeing this in other math classes, f of g of x, like that? And you took g and you plugged it into f. Okay? So that's what we're doing here. It's called composition of functions. We're putting the inverse into the function. So in this case, we've got the inverse and the function, and we're checking to see if it really is an inverse. So in this case, I would check f of f inverse of x. So I would take f inverse of x, which is this right here, and I would plug it in for x. And so when I do that, I would have 3 times x plus 2 over 3 minus 2. Right? And if I do this problem, that 3 is like a 3 over 1, right? These 3's right here are going to cancel. And that leaves me with x plus 2 minus 2. And what is x plus 2 minus 2? Just x. Okay? And if you get x, that's telling me these are probably inverses. I also have to check the other way. I also have to find f inverse of f of x. So this time, I'm going to take 3x minus 2 and plug it in over here. Okay? So I'll have 3x minus 2 plus 2 divided by 3. Okay? What cancels first here? Not the 3's. The 2's cancel first here. The negative 2 and positive 2 cancel first. So we have 3x over 3. And then the 3's cancel and we get x. We can't cancel those 3's while we still have plus or minus signs in the numerator. So we would do the 2's first. So negative 2, positive 2 is 0. So since both of these equal x, yes, these are inverses. Okay. if you get anything in the world besides x, then they are not inverses. If you get 2x, if you get 7x, if you get x plus 1, if you get x squared minus 4, if you get anything besides x whenever you do this, then the two functions are not inverses. So on tomorrow's quiz, if you're stuck and you can't figure out how to solve it like we did at the beginning of class, okay, you can't figure out how to do it like you did at the beginning of class, then you could do the f of f inverse and see if you get x. If you get x, then it's the correct answer. So out of the 4 answer choices, one of them should work. So that can help. The last thing we're going to do here is, for this one, we can also use this to help us check our answers. So I have this equation, y equals 9/5 x plus 32. So I'm going to find the inverse of this. I'm going to switch the x and the y. So x equals 9/5 y plus 32. Okay, so I could subtract 32 from both sides. So I get x minus 32 equals 9/5 y. Oh, and then we've got that fraction to deal with. Oh, but remember, fractions are just numbers, right? They're just numbers. So if that was a 2, what would I do with the 2? I just divide it off, right? So I just divide it because it'd be 2 times y, so I just divide that 2. So I just divide both sides by 9/5. But if I do that, gosh, the side over here is ugly, right? It has a fraction inside of a fraction. It's called a complex fraction. We pretty much are never going to see them leave an answer as a complex fraction. So, so if I think about this, to divide fractions, how do I divide fractions? Multiply, flip the set. I always tell kids, I don't know if I've said it in here yet, but dividing fractions is easy as pie. Flip the second and multiply. So we're going to have, the second is the 9/5, so we'll have x minus 32. And then we'll flip that second fraction, so we'll multiply by 5/9. And what I would do, I would probably just write it like this: f inverse of x equals, I'd probably leave that 5/9 out here and have x minus 32. Probably write it like that. You can distribute that 5/9 if you want to. I'm going to leave it alone because 5/9 and 32 are not going to multiply together very easily. So I'm just going to leave it like it is. Okay, so this is our inverse. And if we want to check to make sure that we did it right, we can take this inverse and plug it in for the x up here. So f of f inverse of x would be, we'd have 9/5 times 5/9 times x minus 32 plus 32. So I would need to multiply this 9/5 by the 5/9 here. What is 9/5 times 5/9? It's basically going to cancel out. It's going to be 1, because you'd get 45 over 45, which would be 1. Or if you want to think of it this way, the 9's cancel and the 5's cancel. You can cross cancel, and you just get 1. So that just leaves us with 1, which we don't have to write, and then x minus 32 plus 32, and then that's just x. Right? So that should make us feel pretty confident that we got the answer right there. If you don't get x, you've messed up somewhere, either in checking it or in doing the problem. Now, technically, we are supposed to check the other way around, but I can't really think of any examples where it works one way and doesn't work the other. So if you're just checking your work, this is probably good enough to know that it is correct. So this will probably be good enough here. All right, so your assignment for tonight is going to be from your book this time. It's going to be page 156. And you'll have these numbers right here, except I do not want you to do number 30. You have to complete the square for number 30, and we are not ready to do that yet. So skip number 30, but the rest of them here you should be able to do.